Okay, we have already discussed. Okay, so I will ask somebody, what is the characteristics of stationary data? Anybody? Hello, anybody please recall what is the characteristics of stationary data? Hello, anybody please recall?
Mean variance are constant.
No, you have to tell one by one. Mean constant.
Reverting
Variant,
mean.
variant. No. Please, madam, please. Hello, madam, please listen. Oh, you are going on telling, you are not listening. Mean constant, variance constant, covariance constant. Like that, you need to tell one by one because each is a characteristics. All constant you can tell. Then you are writing only 1 point. Okay, so you have to write 3 points: mean constant, variance constant, covariance constant. That tell now. Yes.
P value is less than 5%.
Which value?
P probability value. P value.
We never discussed that. We have never discussed, madam. We have never discussed that. What are the characteristics? Again, tell me quickly. Others, please tell. What
It's
are the
mean reverting.
mean reverting? Yes.
Beta 1 less than 1.
Beta is less than 1. Yes. One more. Mean constant, variance constant, covariance constant. All right. Then it is a mean reverting. Okay, beta value is less than 1. Then
Series is stationary, then R square less than Durbin-Watson.
don't tell whatever we have not discussed. Okay. So
There is a no outlier.
yes.
There is no outlier.
We have never discussed all these things. We have never discussed all these things, which means you have not written properly. You have to write. I'm going slowly, but you have to write, madam. You have to write.
Okay.
Whenever we ask about this one, you cannot mix with others, which means your understanding will become this one poor. You have to tell this is this, sir. Like that you have to tell. So you cannot beat around the bush. Please understand. Right? That, this, that you cannot tell. So then there will be correlation. There will be autocorrelation will be there. Okay, so autocorrelation will be there. Very good. So now let me, have you noted down everybody? Pooja madam, can you repeat?
Yes, sir.
Yeah, please repeat, madam.
Mean is constant. Variance is constant. Mean reversal.
No, I have told you covariance constant.
Yes, sir. Okay, sir. Sorry, sir. Covariance is constant, and there is an autocorrelation. Okay.
Mean reverting.
Mean reverting, right, sir.
Beta is less than 1.
Beta is less than 1.
Please
Okay.
write down. Otherwise,
Yes,
you will not understand. Please write down. Very good. So now, today we are going to tell how we are going to check whether the data is stationary or not. All right. Okay. Now, for which we have a test. Okay. Now, these are all okay. Now, so the yearly and pioneering work for testing unit root for the time series done by Ticky and Fuller in the year 1979 and Fuller alone in the year 1976. Now, in econometrics, we need to know the equations. We need to know some kind of derivations. Now, in the first slide, I didn't tell because we are having it here, right? So now, y is equal to beta yt minus 1 plus ut. Right? Somebody, can you describe what is this one? Hello, please describe. Somebody, please describe. What is the equation? What are the contents of that? Somebody please describe quickly.
So yt is equals to beta yt minus 1 showing lag period plus random term.
Okay, random term, UT, error, right? Random term, error, right? Very good. So what is beta?
Beta null hypothesis is beta is equals to
No, madam. What is beta?
Coefficient of yt minus 1.
Symbol. The coefficient of yt minus 1. That's all.
yes.
Don't go further. So now we are going to test whether yt has a unit root or not. That is the yt is our series variable. Whether it is having unit root or not, for which our null hypothesis beta is equal to 1. Beta is equal to 1. All right. What do you mean by 1? 1 means 1. Right. So that is the 1 unit 1. Right. Alternate hypothesis is beta not 1. If beta is equal to 1, okay, that is the null hypothesis, right? Which means yt has a unit root. Okay, so now this is clear. Now, what is null hypothesis? Beta is equal to 1, which means yt has a unit root. That is the null hypothesis. But we should not have unit root. Then it will not be stationary, because beta should not be 1, right? A beta equal to 1 is non-stationary. Beta should not be 1, but our null hypothesis is beta is equal to 1. Okay, so we have to reject the null hypothesis. Then only data is stationary. Clear? Clear, everybody? Beta should not be equal to 1 is the null hypothesis. Okay, which means beta is having unit root. That is why we will say not stationary, or people will say data has unit root. Beta has the yt has a unit root, which means beta is equal to 1. Okay, so we want to reject the null hypothesis, which means when you are rejected, which means beta is not 1, which means it is stationary. Okay, now what I am doing is I am subtracting yt minus 1 on both sides. So which means yt minus 1 equal to beta yt minus 1 minus yt minus 1 plus ut. Clear? I am subtracting yt minus 1 on both sides. Very good. Now yt minus 1, current one minus earlier one, that is called delta yt, difference. What is difference? So today minus yesterday, that is the delta yt. So delta yt. So now what I am doing is, okay, here this is same. So what I can do is I can take beta outside. How I can yt minus 1 outside, which means beta minus 1 into yt minus 1 plus ut. Okay, now okay, I am writing this one in the form of, okay, delta yt minus 1 plus ut, which means delta equal to what? What is delta here now? Hello, what is delta? Delta equal to
Beta minus 1.
Beta minus 1. Now, okay. Now, normally in a regression equation, our null hypothesis is there is no influence, which means beta is equal to 0. Now here, this is our equation. This is our equation. Delta yt equal to, this is small delta yt minus 1 plus ut. Now, normally we will say this beta, otherwise here delta is equal to 0. That is our null hypothesis. So whenever we say delta is equal to 0, Delta is nothing but beta minus 1 equal to 0, which means beta is equal to 1. Okay, so that is our null hypothesis. What is our null hypothesis? Beta is equal to 1. What is our equation? What is our equation? Delta Yt is equal to delta Yt minus 1 plus Ut. That is our equation. Where delta is equal to 0, otherwise a beta minus 1 equal to 0, otherwise a beta is equal to 0. That is our equation. Okay. So now this is okay. Same thing I am writing in same thing I am writing because there is no space. That is why I am going to the next page. Okay. So what is this? What I have written? Writing delta Yt equal to small delta Yt plus the difference of all these things I am writing. If you see there, you can see. Okay. So okay. So that it is not there. That will come later. So that is our equation. Very good. Now this is a Dickey-Fuller test. This is a Dickey-Fuller test. This is a Dickey-Fuller equation. In a Dickey-Fuller equation, delta Yt is equal to delta Yt minus 1 plus Ut. Okay, that is the Dickey-Fuller equation. Now I am going for a accumulated Dickey-Fuller. What is accumulated Dickey-Fuller? Now we are taking two lagged terms, which means Yt minus 1, Yt minus 2. Okay, so Yt is equal to beta 1 Yt minus 1 plus beta 2 Yt minus 2 plus Ut. Okay, so this is the coefficient of this one, this is the coefficient of this one. Now add and subtract beta 2 Yt minus 1. So here I'm going to add, if I want to subtract, we have to subtract from both sides, but in one side itself, adding plus 4 minus 4, nothing will happen. So that is what. So now adding and subtracting beta 2 Yt minus 1. So this beta 1 Yt minus 1, same thing written. Okay, this is also written beta 2 Yt minus 2 written. Now I am writing this one. Beta 2 Yt minus 1 minus beta 2 Yt minus 1 plus Ut. Now, so this is same, nothing happened. Now what I am doing is beta 2 Yt minus 2 minus, see here, this one beta 2 Yt minus 2 minus beta 2 Yt minus 1. So this will become beta 2, both same, delta Yt minus 2 plus this one taken plus this one taken. Now subtract Yt minus 1 on both sides. So Yt minus 1 equal to beta, same thing I am writing, So this also I am writing same thing. Okay, so now this also same, here minus Yt minus 1, because here also we have minus, subtracted, here also we have. So all other things same, this is 1. Now let me bring all Yt minus 1 in one side. All Yt minus 1 one side. Here Yt minus 1, here Yt minus 1, here Yt minus 1. So this is a Yt minus 1 is a delta Yt, which is equal to beta 1 Yt minus 1. This I am writing. Then I am writing beta 2 Yt minus 1. This I am writing all Yt minus 1. So this is extra. This is written. This two. Now I am taking Yt minus 1 outside. Then what will happen? Beta 1 plus beta 2 minus 1 Yt minus 1 plus beta 2 delta Yt minus 2, this one. Now let me take, this is 1. These are all coefficient of Yt minus 1. These are all coefficient of Yt. So let us put it as delta. Let us put this as delta. So other things are written. So it's delta Yt minus 1 plus beta 2, this one. So now normally in a recursion equation, we will say beta is equal to 0. Now we will say here delta is equal to 0, which means beta 1 plus beta 2 minus 1 equal to 0. Beta 1 plus beta 2 minus 1 equal to 0, which means beta 1 plus beta 2 equal to 1. Now you need to understand very clearly. So if you have only one term, we set if it is stationary, it should be less than 1. Okay. If it is non-stationary, then it is equal to 1. If it is only one term, beta 1 equal to 1. That is what we have seen. Now if it is two terms, yt minus 1, yt minus 2. So both beta added together, it should be less than 1. That is what we require. Then only it is called a stationary. So if it is only 1, beta 1 should be less than 1. If it is 2, beta 1 plus beta 2 should be less than 1. That is a stationary. What is non-stationary? Beta 1 plus beta 2 put together equal to 1. That is a unit root. Non-stationary means unit root. Now you please remember this equation. Please see the equation. This equation I am going to write with 3 alternate forms. Okay, same thing. See here, delta yt minus 1. Same thing I am writing. So now, okay, so this one plus all these things. Okay, see. Here you have yt minus 1 only. Here, not only yt minus 1, we have a beta 0. What is this one? Anybody? Can you react? What is this one here? Beta 0?
The constant intercept.
Intercept. That is the intercept, right? So here only lagged terms. Here we have a okay. So here we have a drift intercept. Here with this one plus drift plus this is called a trend. This is called a trend. So in the equation we can have 4 components. One is an intercept, another is a trend, another is a stochastic portion or lagged portion, and another is a error term. This 4 portion we will have in a normal equation. Okay, so this is the Accommodant-Dickey-Fuller equation. This is the, now you please write it down. Please write it down, or this also you can write it down. Same thing. Okay, same thing in all different form. Okay, so now please write it down. If you have used only lagged term, then you will get only this much. If required, you will get this one. You will not get this one, but if necessary, it will come. Otherwise, it will not come. Okay, when you use a intercept, you will get intercept and this one. Here, delta yt. Here, delta yt. But here not delta, you need to remember. This is at level. So here this one trend and level. Here delta yt. This will come whenever required. So all these things I will demonstrate. Okay, but how it is coming, but no teacher will tell how it is coming, all these things. So okay, so now here today we will try to understand that also. Okay. Now we are going to have 3 tests. One is called Accommodant-Dickey-Fuller test. Then another is called Phillips-Perron test. Another we have called KPSS test. All these tests, 3 tests we are going to see. Okay, so okay, so that I didn't write. Okay, very good. Now Adf test is used for larger and more complicated time series. It will give a negative number. More negative means stronger the rejection. Like that, we have a Phillips-Perron test. What is the difference? It is written. Okay, what is Phillips-Perron? Phillips-Perron also equation. See the equation. Here delta, here only lagged. Here lagged. But KPSS test. Okay, KPSS. So the equation is here not the difference, here at a level, here at a level. Okay. So that you need to understand. Okay. Now. Okay. So now we will go to the problem, then we will try to understand. Now I think you should have noted down the equations. Okay. Then you will understand. First, okay. Now how to identify. Okay, by using unit root, you can identify very simple, right? You need not struggle. You can use. Okay, so now let me go to the unit root. Okay, first. So now let me take up this one. Okay, I'm taking GDP. Okay, first let us look at the graph. Okay, so we will see all. Okay, first from the graph we can understand. Now let us go to the graph. Then we will go to the test. So when your data, see here, all data for different period, all data points are connected. When all data points are connected, the graph is going like this, which means it is not a mean reverting. It is not coming back to mean. So mean will be probably 6,000. So it is not coming to 6,000. It is going up and up. So this is the stochastic trend. This we call it as stochastic trend. So we will show what is there are two trends, stochastic trend and a deterministic trend. Okay, there are two stationary, different stationary. If it is a stochastic trend, we should difference. Okay, then the trend stationary. That two things will come. Okay, so this is by looking at the graph. Okay, now this is a non-stationary graph. Now I will show the stationary graph. Okay, what is a stationary? How the stationary graph will look like? Okay, so, okay. So now okay, this is a stationary graph, otherwise called mean reverting. Mean reverting, going up, coming down, going up, coming down. So this is a mean reverting. This is a stationary graph. That is the non-stationary graph, number one. All right. Okay. So this is the by looking at this one. Now we are going to look at the. We are going to look at the. Okay. So now we look at this one. Okay. We will look out to this one. Parallelogram. Parallelogram. Okay. So here it is not that visible. Okay. So I will show something else, so that it will be better to see. See written non-stationary data I need to show, right? Okay. Okay, so now No, this is a non-stationary data. Slowly it will come. It will not come very fast. It will not come very fast. So this is a non-stationary data by looking at the Carlogram. Right. So now I will show some data. So where, how this one will look like. Okay, so that stationary data, how the stationary data will look like. Okay, so here itself, I will write. Quick series. Generate series. Here itself I will generate. So y equal to nrnd. So now sample. Let me make adjustment of this sample. Okay, so range itself I need to put. So here I have to write a little carefully. And 206 06 okay, comma 2012 okay 2206 not 06 12 we put 12 0 1 2 okay, sample adjustment I am doing. It is going beyond this. Okay, which means we will take some other data. Okay, we will take some other data. So that otherwise I will generate a new series that will be better. Okay, new work file. So I should open this work file. Let me generate a new work file. New work file. Hey. New work file. So here let me put unstructured, undated. So here 500. Okay, now let me go to the this. I'll close that. So I've closed to something else. Okay, so I will take some other data. Okay, which is stationary. CMR data I will take, which is stationary one. Okay, so now I'll take this CMR. See here. So this is a stationary. This is stationary. Now from this itself we can understand. Non-stationary means it will come very slowly. Stationary means 1 or 2 spikes. There is autocorrelation. Here there is autocorrelation. Okay, so the first point, by looking at the graph we can tell. Okay, if it is a stationary, mean reverting. If it is non-stationary, trend. That is one. Number 2, okay, so number 2, by looking at the Carlogram, so it will be slowly, it will come down. Here it will come down very fast. Okay, so decay, exponential decay. This is called exponential decay, quickly decay. Okay, so this is a stationary data. Okay, that is number 2. Number 3, we are going for, okay, number 3, we are going for the unit group test. Okay, so all those 3 tests we are going to use. So now what to do? Now let me take this data itself because it is open already. Now view, please note down, view unit root test at level at none. First, I should see at none. I should see. Okay. Here, we have to look at this one. We have to look at this one. We have to look at this one. Okay. So normally people will teach all this only, but I will come little further. Now we have told you what is the null hypothesis. Okay, data OIT as a unit root. That is the null hypothesis. What do you mean by unit root? Beta is equal to 1. That is the null hypothesis. Now, which means we want to have stationary data, which means we have to reject the null hypothesis. We have to reject the null hypothesis. Okay. So we have to reject this. I think everybody should have understood. Okay. So now please understand. Okay, our null hypothesis. Here, null hypothesis itself written. That is the beauty of this software. So null hypothesis CMRY has a unit root, which means beta is equal to 1, non-stationary. We are accepting beta because probability is greater than 0.05. We are accepting the null hypothesis, which means data has a unit root. Okay, so now what is this t value? Okay, we are performing the accumulated TQ filter test. Okay, we have performed which accumulated TQ filter test. So in accumulated TQ filter test, okay, so what is the equation? Let me show the equation. Let me show the equation. So now I have not taken intercept. Okay, so see here delta VT, this one. Okay, so delta of, so with this is difference, this is at level -1. So now let me show and whether it is I am getting that. Okay, now see here. Okay, you come down further. So come down further. See here. This is the equation. D. My dependent variable is difference. Okay, D is equal to, see here, the what is this delta? This one. YT minus 1. This is the delta. Okay, delta. YT minus 1. So now this is the T statistics. This is the equation. This is the equation. So this is the T statistics. So that is the T statistics coming here. That T statistics is coming here. So please note down this T statistics minus. Okay, so that is why I have told you. So T statistics in accumulated TQ filter, I will get a minus. So don't worry about signal, the minus or plus. Now what happens? This is even less than 10% level of significance. So that is why we are not able to reject the null hypothesis, which means data is stationary, not stationary. Now what I am going to do is, okay, so now I am going to run. Next, what I have to run? Unit root. Then I have to go to intercept. Now I am clicking the intercept. Now I am clicking the intercept. So now, which means I am including the intercept. My active filter, TQ filter will be delta YT equal to beta plus, okay, beta 1 YT minus 1. Okay, that will be my equation. Okay, now let us see. Now let us see. Okay, so now let us see the equation and we will come. See here. Here delta YT equal to C. This is a C value plus this is a delta C YT minus 1. Both are significant. Both are significant. My T value is minus 3.75. Okay, now let us see. Now let us see here. 3.75, which is less than 0.05. Less than 0.05. Okay, which means it is less than this. Okay, so Madam, some people are waiting in this one, so it is coming and disturbing. So you please allow them. So now I have demonstrated the equation. Now here my significant value is less than 0.05, which means this null hypothesis is rejected. Null hypothesis is rejected. So what is null hypothesis? CMRY has a unit root. That is rejected, which means does not have unit root, which means less than 0.05. Okay. So now, which means the data is stationary. Now, okay. So now I have demonstrated the equations. Okay. Still, I further demonstrate. But let me put it in a very simple way. Okay. So we have to look at this probability value. If this probability value is less than 0.05, which means data is stationary, symbol. Okay, let me tell again. If the probability value is less than 0.05, then data is stationary, right? Somebody please respond. What we have to do? Unit root test. What we have to do?
If p value is less than 0.05, then we reject the null hypothesis and accept alternate. Data is stationary.
Okay, madam. Whatever you are telling is right, but we should know very simplified form. Okay, so when this is less than 0.05, which means data is stationary. That's all matter over. Okay, so now here, McKinnon 1996, this is the p-value, one-sided p-value. Why it is called one-sided p-value? Why it is called one-sided p-value?
Since it is negative.
Okay, so now what is my null hypothesis? Null hypothesis is beta equal to 1. That is my null hypothesis. Unit root beta is equal to 1. Now, whenever I reject the null hypothesis, beta not equal to 1, which means it may be greater than 1 or less than 1. Right? So both possibility is there. See, whenever we reject null hypothesis, which means beta is equal to 1, rejected means beta not equal to 1. It may be greater than 1 or less than 1. But to make it stationary, we want beta should be less than 1. So we should look at the one-sided only. So that is why all t statistics here are less than 1. We are looking at less than 1. Okay, so that is why one-sided p-value, right? So we know we have used SIC, that is why SIC is coming. Right. Okay, so we have seen this. This is the regression equations we can write. Okay, so that is the accumulative filter equation. Okay, so now the problem is not at over. Okay, now so this we have demonstrated CMRY. Now I will demonstrate something else. Okay, that is more interesting. What is that? Okay. So now I'm going to this ADF. Okay. So now let me delete. I have something. Some data. Delete. So that also I may delete. This also let me delete. Okay. Now I have 4. I have 5. Very good. I have 5. So let me take up one by one. Let me take up one by one. Y1. Okay, I have taken Y1. Okay, from this itself you can tell. But we will go to unit root. Okay, test. So first view. Here also I can go. Otherwise, in quick also I can go. Quick also. Series statistics, unit root. Here also I can go. Here also. Here, here I have to write OR. Here. Okay, unit root test at the level. First, we will check with the none. Okay, none, which means we do not have intercept, we do not have trend, only we are checking for lagged one. So now, somebody respond whether it is a unit stationary or not. Somebody please respond.
It is not
Yes, sir.
stationary, sir.
Yes,
It
It
is
is not stationary.
Unit root.
stationary.
Very good. Okay, very good. So now I have used only none, right? That is why d of y1 here y1 minus 1, right? Okay. So this is the t value minus 17.5. That is why it's right. Very good. So now first I check whether it is having any intercept portion. Whether it is having some intercept portion. Okay, in the data, whether there is a intercept. Now, what is this one? What is this one? Now tell me the result. Quickly, tell me the result. Hello, madam. Sorry, madam is not there. Eh?
Yes, sir. Yes, sir. I am there, sir.
Ah, very good,
Sir,
madam. But I
it
have
is
not.
stationary data, sir.
Ah, very good,
Stationary
madam.
data,
Very
sir.
good. Ah.
Yeah.
Very good, madam. Okay. Now,
Okay, sir. Thank you.
madam. Okay.
Yes, sir.
Now, in the equation, what are the things will appear? I have included intercept. So
Yes, sir.
yt minus 1 will appear plus c will appear. Now, okay, because I have included intercept. Now let us see here. Y1
C.
minus 1 plus
On
c.
C.
Okay, plus c. Okay. So now, okay, now, madam. Okay, now it is good. Okay, now this actual y1 is not stationary. Actual y1 is not stationary. But if you remove the intercept, then it is stationary because there is a presence of intercept. So to remove that, we can take the difference, that is a simple solution. But we will remove only the intercept. We will remove only the intercept. Okay, now how to find out intercept value? Okay, now how to find out C value? Okay, now quick estimate equation. Y1, my variable is Y1. I am writing C. I am writing C. Then I have some intercept value 30. Okay, so now this 30 let me remove. Okay, let me remove this C from the Y1. Okay, so how to remove? I'm going to generate a data, generate GENR. Okay, this generate is available in many places. Here I can have a generate. So now let me put CY1. I'm writing CY1 equal to Y1 minus 30. I'm removing that intercept. Removing my intercept. Okay. So now I have a CY1 where I removed the intercept. Now let me check whether it is stationary. Unit root. Now go here with none now, right? Level not none. See here 0.007 stationary. Okay. So if there is an intercept, find out what is the intercept, remove that. Okay, that is what I have done. Okay. Now let me go to the second one. So Y1 is over. Y2. Let me go to Y2. Now view unit root none. So now is it stationary? Not stationary. It is not stationary. Now let me see whether it is having intercept. Okay, intercept. Still it is not stationary. Now let me see whether it is having intercept, trend and intercept. Here trend means deterministic trend. Okay, deterministic. Yesterday we were telling 0.5 into t, like that we have put. Okay, so now is it stationary? Is it stationary? Hello, somebody please recall, is it stationary?
No, sir. No.
No, not stationary. Okay, so which means, okay, trend is not there. Now I'm going to, now the all exhausted. Now I'm going to see the first difference. Okay, so which means the stationary not stationary, not due to trend, not due to intercept, but it is a random walk. That one, beta is equal to 1, right? That one, that, okay, yt minus 1, that is a rising trend. That is a rising. So now let us see first difference, none. First difference, we will try with the none. First difference. Okay, now it is stationary. Now it is stationary. Okay, so now I am going to generate the first difference. How I am going to generate? Okay, so I am going to generate, because okay, after taking difference, it is becoming the stationary. So I have to take the difference now. So how to take a difference? Quick. Here also we have generate series, or here also we have generate series, or we have, okay, so here when you, okay, so okay, so I will have one more place also. Okay, so that I will come later. So now let me use this one. Generate series, generate by equation object. So it is not there coming in. Okay, we will use this one and we will see. Okay, so now here generate, we will use this generate. We will put difference, right? Okay, we will put difference of yt. We will put the difference of yt, which is equal to d. Please note down d within bracket difference of y2. Difference of y2. So I will generate dy2. This is a name. Anything can do. So you can put Alisari madam. Okay, Alisari equal to like that. I can put any name, that is it. So difference of y2. That is the point. Okay, difference of y2. So now what is the difference that you need to understand? What is the difference? Okay, so what is the difference? Now let us open both, then you will understand. Y2 and difference of y2. Let me open both. Let me open both. Now see here, what difference is, I have told you not difference. So this minus this one, 28 minus 28. Next is when I come here, the difference is this minus this minus 6. When you come to here, 39 minus 12. This. So this is called the difference. Difference. Okay, difference. Okay, so difference, right? So which means we are capturing only the change, that here change, that difference. Okay. Very good. So now we have a difference. We will open this one and we will see whether it is stationary or not. Unit root at level at none. Now let us see. stationary. So, when it is not stationary because of trend, stochastic trend, we will difference the data and it will become stationary. Okay, so how to take difference? D of, simple matter over. Okay, next is Y3. Okay, so now, for example, we have taken a difference now that we will see. Okay, how the equation has come, right? That I have not demonstrated. Now, Y2 I am taking. Y2, okay, it becomes stationary by taking difference. So, my equation will be difference of difference. Otherwise, D within bracket Y2 comma 2, which means second difference. Y2 comma 2, second difference. Difference of difference. Equal to, okay, now let us see, only none. So, which means how the equation, now let us see. So, this itself now difference. This itself, earlier it was Y2. Now, this itself difference. Now, this will be difference of D, Y2 comma 2. Here, difference of Y2 minus 1. We have not included any intercept. Now, this is the data such difference of Y2 minus 1. But dependent variable is difference and the difference of Y2. Okay, so that is what. Okay, very good. Okay, now let us go to Y3. Okay, view unit root at level none, nothing happens. Okay, let me take let us not waste time by taking intercept. Let me go to first difference, none, nothing happening. Second difference, nothing happens. So now now what happens? See here how so much a difference it has taken. So much difference it has taken. But even then it is not giving the result. Okay. Now, okay. Even after taking second difference, it is not stationary. Okay. Okay. What do you mean by that? It is not stationary. What do you mean by that? Hello, what do you mean by this? Hello, anybody?
Sir, this is unit root, sir.
Which one, madam?
What? See, after taking the first and second differences, still it is unit root.
Still, it is not stationary. Okay, what do you mean by that?
That means beta is equal to 1. Sorry.
So, non-stationary means beta is equal to 1 only. But here, even after taking second difference, when it is not stationary, which means the data is exploding. Data is, there is a exponential growth. That is the exploding.
Which means, sir?
Which means, you please tell me, which means, what do you mean by exploding?
Beta greater than 1.
Beta greater than 1.
Greater than 1 is
Yes.
said. So in this case, the data is multiplying like anything, or see what is the...
See here. See here, how growth, it is not an ordinary trend. So now, see, please remember, when beta is, let us assume that 2, beta is 2, then what will happen? If today is 10, okay, so 10 into 2, 20. Next year, 20 into 2, 40. Next year, 40 into 2, 80. So it will go like that. So there will be a exponential growth that we call it
So
as
in
a
the case,
explode.
excuse me, sir. So in the case, suppose if the national income of a country is like this, if the data is coming like this, means the income is growing like anything, isn't it, sir?
Yes,
Growing exponentially.
exponential growth.
Okay, sir.
Exponential.
Okay, sir. This is what the interpretation I.
Okay, explode.
Okay, sir. Thank you, sir.
Now we will see. We say that it is a exploding. Now we exploding means beta is equal to greater than 1. Now let us see beta is greater than 1 or not. How to find out beta is greater than 1? What I have to do? Quick estimate equation. What I have to do? Please tell me. Y2. Okay, so leave alone C. Okay, Y2 within bracket minus 1. Okay, so now I will get a beta value. Okay, Y2 cap. We can put the C also, but I have not put the C. Simply I have written Y2 within bracket minus 1, which means Y2 minus 1, YT minus 1. Okay, so now let us see the beta value. So the beta value is 1.009. Okay, so that is why beta is greater than 1. That is why data is exploding. Data is exploding. So if you take the any economics data, 95% of the data will become stationary after first difference. Remaining 4.5% of the data will become stationary after second difference. Very rarest of the rare cases, you will have this situation. Now, that is Y3. Now let us go to Y4. Y4. View, unit root, at level, at none. Right. So it is not stationary. So which means if you look at the equation, okay, so it will be okay only variable y4 minus 1. Okay. So now let me take the next one. View unit root. Here intercept, let me try intercept. It is not stationary. Let me try intercept and trend. Intercept and trend and intercept. Which means in the equation, okay, intercept will be there and trend will be there. Now let us see what happens. So now it is stationary. Minus 4.4. Now, okay, now if you see here in the equation, so y4 minus 1. See, this is at the rate of trend. At the rate of trend. This is also significant, which means intercept is not significant. Mainly trend is presenting. Trend is present. Okay. So now, which means now, now we have demonstrated this is a 4.1, it has come. Now, the data is stationary after taking trend, which means there is a deterministic trend. Then we have to treat trend to make it stationary. We have to detrend it, detrend. So how to do? So which means we need to know that trend coefficient at the rate of trend. See here how trend is coming at the rate of trend. I want to see this coefficient. Here we have put this is the coefficient y4 minus 1 means I will get this coefficient. I will put C means I will get this one. If I put at the rate of trend, then I will get this one. Okay, so now let us see what is that value. Okay, so now let me go to the quick estimate equation. y4, okay, I can put a C, otherwise not necessary. Then at the rate of trend, 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 and y4 minus 1. So my y4 is 0.85. This trend is minus 0.9. Minus 0.9. Okay. So otherwise, if you put a simply trend also, you will get some coefficient. Okay. So now let me remove this one. Let us see. Otherwise, because we have put this minus also, but we will remove that. Otherwise, we will put only trend and we will remove. Okay. So now, what is this value? 0.9. Let us put 0.93. Okay. So now, how I am going to do? Quick generate series. Now it is ty4. I'm writing trend y4 equal to y4 minus 0.093 into at the rate of trend, at the rate of trend. Okay, this is the coefficient, this is at the rate of trend. I'm removing that. Then I am getting this one. Okay, now let me see whether it is. So now I'm going to put, okay, first level none. Okay, what happens? I have selected ty4. Okay, ty4. D of ty4. Now let us see. So now I think we have done some mistake. We will see. Okay, now quick estimate equation. Okay, y4. So at the rate of trend, we put at the rate of trend. At the rate of trend. Okay, so now we will get to the coefficient 0.63. 0.63, right? Let me remove 0.63. Okay, let me remove 0.63. So let me go to generate, where I can go to generate. So here also it is there. Okay, so rock. Okay, this generate series object, generate series. Now ty4, any name I can give, ty4 equal to y4 minus 0.63, yeah, minus 0.63 multiplied with at the rate of trend. At the rate of trend. So that, okay, that, okay, fine. So now I got ty4. Now view unit root at none, nothing, right? Now if I say that it is stationary, it is there. So find out the trend coefficient by using the equation y4 at the rate of trend. Then you will get a coefficient. Then how to remove y4, that some name equal to y4 minus 0.64 into at the rate of trend. If you write like that, you will get. Okay, so these are all the ways by which you can remove the trend. Very good. Now, okay, now I have shown so far the accumulated decay filter. But now let me show the other one. Let me take Y2. Let me take Y2. Okay. So now how to perform? Now here. Okay, unit root at level. Here see what I have taken, accumulated decay filter at none. Okay, so normally we will take intercept y and time. Okay, so not stationary. So now let me take unit root. Let me take first difference. It is stationary. So now I have taken accumulated decay filter. Now let me go to Phillips Heron. Phillips Heron unit root at first level. Okay, so here I am changing Phillips Heron. Okay, here I am changing Phillips Heron. Now when I take a Phillips Heron, here we are using automatically it will come default Bernard kernel. So that is the estimation method. So now bandwidth is new way and west. This is what we are using. Now here, okay. So now we will see this one. After that we will see. Now, okay. Now earlier in accumulated decay filter we will get only this one. We didn't get this one. So this is the special with the Phillips Heron. Why? Because what Phillips Heron is doing. Okay, now see if we come to bottom, now what we have taken? Y2, right? Y2. All right. So now here in the bottom, we should get D of Y2, right? That is the D of Y2. So it is similar to accumulated decay filter, but here instead of 0.12 here, you can see. So here T statistics is. So here this T, what is T statistics? Coefficient divided by standard error is the T statistics. But here the T statistics in here it will be different, right? So now we will check whether it is stationary at the first difference as per Phillips Heron. So view unit root test. I will go to Phillips Heron first difference. So this is stationary. This is stationary. Here is adjustment adjusted. Now see here. It is earlier we have seen only T statistics. Now it is adjusted. Phillips Heron is making adjustment for petrocatastatic and autocorrelation. For both it is adjusting. For both it is adjusting. So now you can see here. You can see. So it is 14.87 here. There it is not making many adjustment. There will be small adjustment. In a ADF, it will be same. Here there will be small adjustment. Now I will tell where is the real difference between the ADF and the Phillips Heron. So now we will take up this GDP data or that. I do not know whether this is that data, this data. We will take up that itself. This itself. Okay. So I'm taking GDP. Now I'm checking unit root. Level, intercept. Now here it is not stationary. Now if you go down, you can see many things. Earlier, we have seen only GDP -1 and C because we have included intercept. But it is taking different lactic terms. It is not GDP minus 1. It is taking different lagged terms. It is taking different lagged terms. Okay. So now we will check at the first difference. Then what happens? Unit root at the first difference, intercept. So now it is stationary, but now also you can notice. So difference, we have taken difference, so that is why difference, we have a double difference. So not only this one, so difference lacked, two difference lacked terms are included. So now, but ADF is 3.02 T statistic. That you can see 3.02. So here T statistics will not change. Rather, in a ADF, if there is an autocorrelation, and it will take its own lagged term, difference lagged term. So now if you see the equation in ADF's equation now, so difference, okay, whenever this one, the data is, the equation is difference of that, then not only this one, but also see here, difference lagged terms, sigma, many lagged terms, it will add so that the serial correlation will be removed. So far we have seen up to this one. So far we have seen up to this one. Okay, so but ADF, what it will do, it will make adjust, if there is a serial correlation, it will make adjustment by taking difference left terms. But now let us take the, okay, so we will take the Phillips Ferran. Now, okay, so we will run Phillips Ferran. Unit root. Here, let me take a Phillips Ferran. So first at level at this one we will put. It is not stationary. Unit root at a difference. It is not stationary. It is not stationary because, okay, many lagged terms. If you go to second one, it will be stationary. Because that it is taking adjustment by taking the lagged terms, so it will not do that. But rather, sometimes what will happen, it will make adjustment in the T statistic 7.9. So it is taking my adjustment in the T statistic. Okay, so that will happen. Now we will go to one more, that is the, okay, so now you have to note down the equation also, how it is coming. That is why we have shown the equation. Now we will show the KPSS test. So here we have a KPSS test. KPSS test at level. Now here the difference is null hypothesis itself different. Oh, we will show what is the null hypothesis. Here, what is null hypothesis? GDP is stationary. GDP is stationary. That is the null hypothesis. Which means we should accept. We should accept. We are accepting it. So here null hypothesis stationary, which means, okay, so data is stationary at the level itself. Now the equation also here, it is not different. See here, the equation also. Okay, so now, these are all the different tests. So you can look at the in the PPT I have written where what is the difference. Okay, where you have to use. Okay, so here comparison. Okay, so now TQ filler. Okay, so it may be retrostar. Okay, here. Okay, so but serial correlation will present. To account for this, accumulated TQ filler test regression includes lakhs of first differences of IT. Like this, it will come. So Phillips error test involves that it calculate T statistics. Okay. So yeah, maybe so PV test correct for any serial correlation under catastaticity in the errors by non-parametrically by modifying the equivalent T statistics. That is okay. So this is the Phillips Perron equation. So KPSS test, it is taking same thing. Okay, now, okay, so each is having advantage and disadvantage, but ADF test is more powerful, and more useful. So people can rely upon. Okay, okay. Here I have written when KPSS and ADF give different result, what we have to do. That is also I have written. Okay, so you can go through. Okay, so when both give a different result, then which one you have to choose? That is what you have to do. That is also written. But let me tell you finally, when your sample is small, okay, you can prefer KPSS. Then if your sample is large, it is better to go for ADF. ADF is better than all other tests. All other, that is why many people they use only ADF. They will use only ADF. Okay, so this is with respect to the unit root. Okay, so this is with respect to unit root. Now if you have any doubt, you can ask me. You can ask, right?
Hello.
Hello, sir. Tell me, sir.
Hello, sir.
Yes, sir. Yes, sir.
Yeah, what is the difference
Yes, sir.
between R square and adjusted R square? What is the difference between R square value and adjusted R square value?
Now that you should have asked yesterday, sir. Okay, so but today you ask if there is any doubt on unit root test, sir.
Regarding that, you have written the value of R square and adjusted R square. After looking that, I just confused.
Yes, sir. Yes, sir.
R square value and adjusted R square value. In the
No,
slide I have seen R
no,
square value and
sir.
adjusted R square value.
No, I can tell, sir. I can tell. See now, mm, probably when we will discuss at the time of recursion, I should discuss. So probably when I discuss the war, I can tell how it will make a difference. Okay, so whenever we go for general to specific, but even then now I will tell you R square value. Okay, so it is the degree of determination. Now, what will happen when you increase one more variable?
Okay.
Adjusted R square will increase, but R square will increase. R square, whenever you add one more, the R square will increase. But whenever you add one more variable, adjusted R square may not increase. Which means we are making adjustment for the degrees of freedom, or otherwise we are making adjustment for the number of independent variables. Now if you look at the formula, okay, so you will understand what is this difference. So this is the adjusted R square. Okay, now what we are doing? So 1 minus 1 into 1 minus R square into n minus 1. Here, see earlier we have taken n minus 1. Now we are dividing by n minus k minus 1. So k is number of independent variables. So now when k increases, so now here see here. So R square and adjusted R square. 1 minus. So when k increases, okay, that increase, okay, that is eliminated there. Okay, so now that divided by this one, okay, then you will get lesser, this value will be, okay, now what will happen? Now this value will be lesser. This value will be because n minus k minus 1, this value will be lesser.
Okay.
Earlier n minus 1 only. Now this
Okay.
will be decreased. So now what will happen? This minus small value, that entire value will be more. Okay, now see here. So now we are dividing by, okay, less number of value, which means this value will be more. 1 minus that increased value. So which means adjusted R square will decrease. Okay.
One more understanding.
Now wait. Now because of increase in variable, your R square might have increased, but that might not have increased to that extent of number of variable increase.
Okay.
So that is why what will happen? R square is ranging from 0 to 1. But
Okay.
adjusted R square minus also possible. Minus
Yes.
also possible.
Less than 0.
Less than also possible. Because this 1 minus, if this value more, what will happen? So minus is also possible. So that is why, for example, our model should be parsimonious model. If you add more and more variable, okay, your degrees of freedom will be reduced.
Yes.
Your degrees of freedom will be reduced. So to that extent, R square, adjusted R square will be adjusted. So that is why, if you want to compare one model with the another model, here you might have included more number of parameters. Here you might be having less number of parameters. But now adjusted R square, see R square will be, when you have more parameters, definitely R square will be more. But adjusted R square may not be more. Okay, so I have one example also when we talk about var, where, so now adjusted R square, when we have reduced the number of variables, adjusted R square will be more. Okay, so that will be there. That is why, that is the we need to use the adjusted R square to make a comparison between models.
Okay. Can you use both this model for parametric and a non-parametric test? Can you use this model, this formula for both parametric and non-parametric?
No, I don't understand your question, sir.
Sir, this formula you have given R square value. This is for regression analysis, sir. Whenever you are using regression analysis, it's okay, no doubt. But whenever you are using regression analysis, it's all from parametric. Suppose you are
Which
going
one?
for
Regression is parametric or non-parametric?
Yes. If
No,
it
no.
is
I'm asking a question. Regression is a parametric or not parametric?
parametric.
Okay, then what is your question?
Suppose it's non-parametric. Can we use this R square adjusted R square concept there also?
No, see, you say that a regression is a parametric test.
Parametric.
Right?
Yes, parameters are there. Yeah.
Okay. So which means, okay, so degree of determination, we will use only the, okay, parametric.
Okay, sir.
So now if it is a non-parametric or other things, okay, so we will have a separate parameter. Okay. Yes or no?
Yes.
Okay. Then what is your question? Any more question? So
My
you
question
ask
is,
in the unit root, sir. Yesterday
yeah,
you should have asked.
yeah,
You should have asked these questions, but now you are asking me
under,
to jump.
yeah.
So I can tell
No.
answer.
Under unit root, we are also writing R square and adjusted R square.
Why do you want to write adjusted R square in unit root?
No. My question is, is there any possibility of adjusted R square or not?
No question, sir. No
That
question.
was my doubt. That was my doubt. That was my
Now,
doubt only.
see, here also it is there. See, here also you have that result. Okay, for example, I say this is a regression equation. Okay, in the bottom is the ADF equation is a regression equation.
Yes.
So that is why R square adjusted. Whenever we say R square,
R
the
square is there.
regression equation, R square, adjusted R square, sum of squares, all will come. Yesterday I have shown the wireless. Okay, where I have shown all these things, it will come. So
Correct,
that is why, see, the other people will not, many people, they will not use the equation. But I'm using the equation which is nothing but a regression equation. This is nothing but a
No
okay,
problem.
this is a regression equation. So whenever we call it as a regression equation, okay, you will get all these things. You will get all these things, right? Okay. So now,
Okay, sir.
so now,
I understood. Sir. In
okay,
regression
so
analysis, we are using parametric test. R square, adjusted R square is
okay, so
applicable.
now,
Not non-parametric test. It is not a question of discussion.
now what you need to understand from here. Okay, we are not looking at all these things in a unit root.
That 0, 0, 0, yeah.
We are looking at this T statistics. What is this T statistics? Coefficient divided by standard error is the T statistics.
Yes.
Because we are using this statistics here. That same T statistics is not here. This is KPSS test. So for ADF test, it will come here T statistics. Okay, so that is where we are using. In regression, we will get a T statistics, which is nothing but the coefficient divided by standard error. Coefficient divided by standard error. Right. Okay. So now, So now you should have thorough knowledge about unit root because this is the very basic thing every time we will be using. Because whenever we go for co-integration, whenever we go for even ARIMA, okay, so we should use only stationary variable. So we need to know whether the variable is stationary or not, which means, okay, we need to know, you need to check the unit root. So, okay, so when there is no unit root, which means the data is stationary. That is what, very simple. Now, from all the discussion, what you need to understand is, look at the p-value. If the p-value is less than 0.05, there is a stationary bind. Now, one more thing, please understand. If it is not less than 0.05, so whether we need to take tree trending or we need to take the removing the intercept, okay, so you will have a doubt, but very simple thing, if you take a difference, okay, it will become stationary. Why? Because, see, what is the difference? Okay, see, for example, first data is 1000, second data is 2000, third data is 3000, something like that. When you take a difference, 2000 minus 1000, it is 1000.
Okay.
For example, you take a 1 lakh, 1,00,000. See, first data is 1 lakh. Second data is 1 lakh and 1000. When you take a difference, your data will be 1000. See, 1 lakh is reduced to 1000. When you take a difference, 1 lakh, 1,00,000. When you take a difference, you will get 1,000. So when you take a difference, it is like a very big river flowing. Even a small canal will get filled within a few seconds. So when you take an intercept, you will remove only 30. You remove only from 1 lakh, you will remove only 30. Okay. So if it is a deterministic trend, every time that trend may be, for example, even it is 10. Okay, coefficient is 10. Or let us assume that coefficient is 20. Every time, okay, 20 into t. 1 year means 20. Second year means 20 into 2, 40. Third year means 20 into 3, 60 you will remove. But if you take a difference, you are removing 1 lakh. Okay, so that is why. So simply every time people will take a difference, so it will become stationary. Okay, so finally, if the, okay, so find out p value. If it is less than 0.05, say stationary. If it is not that, take a difference. Okay, so it will become stationary. Most of your data will become stationary at the second difference, right? Whenever you want to forecast, you need to use only the stationary data. Very simple. Now, let me go for a very important, very important characteristics, a very important contribution. So that is the, okay, that is the co-integration. That is the co-integration. Now, I said we have to use the difference data. Now, when you take a difference, I said 1 lakh, 1,10,000, so it will become 10,000. What do you mean by difference? The change. Every year, what is the change? Okay, after taking a difference, you will be having what is the change happened in that year. See, please understand. 10,000, 11,000. That difference, when you take a difference, it will be 1,000. Which means change happened in that year is 1,000. Now, when you take a difference, you are having only the change happened in that year. If you use that difference data in a regression, okay, by using that difference, you are predicting the difference happened in the another. Okay, so here also 1,000. For example, another data 1,000. Okay, so for example, 10,000, 11,000, 1,000. Another data, okay, 20,000, 21,000, 1,000. Okay, so which means your forecasting will be short term. Your model will be short term when you use a difference data. But your data will be having over a period of time. It might have started from 1,000, now it will be 25,000. So you can understand how it has developed over a period of time. How another data developed over a period of time. So you need to use the original data so that we are using the actual value, not difference, only growth. So we can find out the long-term relationship. But we need to say, we say that we need to take a difference. Okay, so when there is a trend which is not stationary, another data which is having a trend over a period of time, it has grown, which is a trend, which is also not stationary. Okay, which means you need to take a difference, then only you can do any forecasting, anything, which means you are losing the long-term information. But I want to use original data, what to do? What to do? Okay, so now I want to find out whether there is a long-term relationship or not. But when your data is having a trend, which is a non-stationary, if you use two non-stationary data, your regression will be spurious. Okay, now we will take some non-stationary data. Any non-stationary data. We will take some any non-stationary data. Okay, any data we can take. Okay, so let us take Nifty future, spot and future. I am taking two data, future and spot. Okay, now let us find out the unit root. View, unit root test. Okay, level, non-stationary. Okay, so this is all non-stationary. So let me take a spot. Unit root test. Okay, non-stationary. Now, if I use, okay, let me use the regression, quick estimate equation. I'm using OLS for this one. So let me put a spot future. Okay, so I'm not taking any intercept. So a spot future. Okay, let me take a spot as future. So 99%. See my Durbin Watson. See my Durbin Watson. See my R square. R square value is greater than Durbin Watson, which means spurious. So which means when you use any two non-stationary data in a model or regression model OLS, you will get a spurious regression, which means you should not use any stationary, non-stationary data. But see, now let us plot these two. Okay, so that will be this one. Okay, let me take a log. Okay, so now that also will be, people will think, okay, so L spot, I'm taking L spot equal to log of spot. This is a, I'm generating a data, right? L spot, I'm giving some name equal to log of spot. O will not come. Log of spot. Okay, let me say yes. Okay, like that. Okay, so let me generate the object. So let me generate here one more. L future equal to log of future. Okay, log of future. Okay, so now one thing please understand. I have already I think I might have demonstrated. When you have taken a log, okay, so now okay, so you please understand this. Okay, so I'm taking future and the spot. I'm taking future and the spot. I'm taking open group. Now I'm for group statistics correlation. Okay, both variable. I'm taking future and spot. I'm taking a correlation. So correlation is 99. Okay. So now let me take let me take not future and spot. Let me take logged data. Log future, log spot. Log future, log spot. So group. Okay. Let me take a correlation. Let me take a correlation. Same 99. Which means, okay, which means whenever you take log, the features will not change. Relationship will not change. The beta will not change. Please understand. Beta will not change. So you can use a logged data also in the regression, right? So whenever you use one logged data, another unlocked data, then you have to use one unit change, percentage change. That words you have to use. Okay, that we will not discuss now. Okay, so now, okay, people say that you have taken logs. That is why I have demonstrated. Now let me take both log data. Let me put in a graph. Open group. So let me put a graph now. Now see, blue is is spot, red is future. Both are moving in the same direction. It is not only for this period, this period, this period. Over a long period, both move in the same direction, which means both are having a relationship in the long run. So in the data, we could see there is a long run relationship, but we are not able to use it. Okay, we are not able to, whenever you take the difference only, we are using only for short term. What to do? Okay, so people were searching what to do. Then people thought they call this is a co-integration. What is co-integration means? Integration, right? When the data is stationary after difference. Okay, now here spot. Okay, now I will demonstrate. Okay, I will tell. So now L spot open. Okay, L feature. So now let me say unit root. So at level it is not stationary. Now if I take unit root at the first difference, it is stationary. So it becomes stationary at the first difference, which means the L future, okay, so approximately equivalent to I within bracket 1. That is a integrated, because different stationary. The original data is a integrated data, which is equal to I1, which means whenever we say I1, which means this is a integrated of first order, which means this will become stationary after first difference. That is the meaning. That is the meaning, right? So it become first the stationary after first difference, right? Very good. So now here, okay. So now let me take a spot. So this also, okay, unit rule. It is not. It is a stationary at not level. Okay, but stationary at the first difference. Okay, so now these two are integrated of order 1. Okay, so both are same, integrated of order same. Now I am combining. See, both are I1. I am combining. Both parents are this nature. For the combination of both parents, now I am getting a child. That child should be I1, right? But if child is I0, how come I0 it is there? How come I0? Which means parents are I0. Not now, in the long term. That is the meaning. Otherwise, okay, two non-stationary variable, when the linear combination, please understand, combining these two, linear combination, when it becomes I0, which means they are co-integrated, simple. Two integrated series, I1 series, when they combine or linear combination, what is linear combination? Yt is equal to C plus xt. Okay, so x and y. Linear combination, combining. Okay, which means y equal to a plus bx plus c. We are putting that equation. The linear combination is I0, which means they are co-integrated. Simple. Okay, so now I will demonstrate. Now, so now here L future, L spot. Okay, now let me put L future and L spot. So I can quick open a symmetric equation that I can write, but I have a simple process also. Now let me put L future and L spot. I'm selecting open as a group, open as a equation. Open as a equation, then I will get the equation future. So I can change here, right? Okay. So now, okay, I'm combining linear combination, which means future is y. Y equal to, let me put a c in the middle, then you will understand better. Okay, c in the middle. So which means y equal to a plus bx. I have written that. Okay. So now I'm combining. Okay. So now the linear combination. Okay. So I put y equal to a plus bx. Now e is there. Now let me save e. Okay. Now e is here. Resid is e. Now let me save in some variable. Proc make residual series. Then some variable name will come. Okay. It is resid 01. Here resid 01 will come. Here resid 01. Okay. So I have combined. I am getting a error. Okay. Now, okay. See here. Y is equal to a plus bx e. That is ut. Okay. Now this is. I am going to check whether it is a unit code. Okay. At level stationary. So both future and spot are I1. When they combined, we are getting a residual that is I0, which means they are co-integrated. Co-integrated. Okay. So now let me take one more example. I will tell you. Okay, so now here. Okay. Now here I have, okay, so LLE. Now let me check whether it is a unit root. Okay, level no. Okay, first difference, yes. Okay, first difference, yes. So like this, I have one more variable that is also similar to this one. Okay, so but wrong example. Okay, so now LLE, life expectancy of China, and the carbon emission of USA. Okay, now I'm combining LLE. Sorry. Now LLE and I'm combining open as equation. Both are I1 now. Both are I1. Okay, both are I1. So now I am now proc make residual. So resid 003, resid 03. So now I'm checking unit level. Not stationary. Both are I1. Both are I1. Okay, so the linear combination, I got a error, residual. The residual also I1. Residual also I1. So both are I1. I combined as an equation. Then getting UT, the error, which is also I1, which is not, which means which is not co-integrated. which means it is simply spurious. Okay, now I'll regression. How to run a simple regression? See here, simple regression. My Durbin-Watson value, look at the R square value. Simply spurious. Simply spurious. So when they are the integrated of same order, their linear combination is stationary at level. Then they are co-integrated, which means there is a long-term relationship is there. We can use the long-term data itself. There is a long-term. We can run with the long-term. That coefficient is the super consistent coefficient. Okay, you can use the non-stationary data as such. That long coefficient is a super consistent. What do you mean by super consistent? So now that will get more faster than when you run with the difference data. Okay, so it will be applicable to the universe population, super consistent. So that is the co-integration. That is the co-integration. Okay, so now we know that it is co-integrated. So our spot feature, Okay, so now let me go to spot feature. Now, okay, so now let me delete whatever I have. Okay, so what I will do is, okay, let me run again. Okay, so L feature and L spot. Okay, I can write here quick estimate equation. Okay, here also I can write. Okay, here let me write L future C L spot L SPOT. And now, okay, now I have a residual. Let me save that residual. Okay, here also it is coming. But I have to save proc make residual series. Okay, let me put this name as Z. Okay, let me put, I'm putting Z, that residual name I'm putting Z. Otherwise, why confusion? Let me put a resid 1. Let me put a resid 1. Okay, resid 1. Okay. So now see here, say, let me demonstrate. Now my resid and resid 1 will be same because that only I have saved in a different name. That only I have saved in a different name. Okay, so now let me check this resid 1 unit root at level. It is stationary. Very good. So which means I say both are co-integrated. Now we have a test. Okay, so this is what co-integration means. Now I have a test. Now test. Okay, now I have a test. So let me not use this one. Let me delete this one. Okay, let me delete. Okay, so now let me open L future and L spot. Open as a group. Now view co-integration test. So single equation, this is a Yankel. There are two co-integration. One is a Yankel-Cranger co-integration. Another is a Johansson co-integration. Now I am running Yankel-Cranger co-integration, right? Now see here, less than 0.05, which means there is a co-integration. Null hypothesis is series are not co-integrated. Series are not co-integrated. Okay, so here it is co-integrated, rejected, which means there is a co-integration. There is a co-integration. So this also, we, instead of checking that this one, we can use this test. Okay, so we can use this test to find out whether they are co-integrated. Okay, so when they are co-integrated, I can run a long run equation. How I can run a long run equation? By taking at a level itself. Okay, but in a short run, okay, so we will take a difference. So short run, some deviation might happen here and there. It will go. So we will be using some error correction. Okay, so here I will run error correction here. Okay, so but I will go there and I will explain what is that value, all these things, right? Very good. So now here let me run a error correction. This is angle corrector mechanism of error correction. Okay, so now what I am going to do is, okay, now I need to take a, because it is a short term, okay, I have to take a difference. Okay, so now let me generate, which means D future equal to difference of L future. So whenever I put a D, date is coming. So I'm taking a difference of this L future. I'm saving. All right. Now, like the same, I'm generating D of spot. D of spot equal to D of L spot. D of L spot. Okay, I'm taking. Now, okay. So my equation is difference YT equal to beta 1 x t, okay, so minus error correction. Okay, otherwise I'll tell it. Okay, now I will write, then you can understand. Estimate equation. Okay, L future, not D future, difference data. Future, D future. Okay, let us not take a C. D spot then I have a residual E. Okay, that is the residual. I have saved somewhere. Resid 1 within bracket minus 1 within bracket. So past error that changed. Okay, in the short run it has changed. So I am bringing. Okay, so it has deviated. So it has to come back. So it has to be detected. That is why minus. Normally error correction coefficient should be minus. Okay, because the deviation should be corrected. Okay, if it is not corrected, then explode. If it is a plus, it will explode. Okay. Okay, now So now it is minus. So now this is a error correction. So d future, short term. So when there is a deviation, so this will get adjusted. Wait for 1 second. Hello? Yes, sir. Yes, madam. Yes, madam. Yes, madam. Yes, madam. Yes, madam. Tell me, madam. Yeah. Yes, madam. Yeah, tell. Yeah, tell me, madam. Okay. 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 Okay, no problem, madam. No problem, madam. I am taking one workshop, madam, for theoretical college. That is why I could not take your phone. Now also it is going on. Evening I will call you, madam. Thank you, madam. Thank you. I will come, madam. No issue. I will come, madam. Definitely I will come. Okay, thank you, madam. Thank you. Yeah, no issue. No, madam. No problem, madam. I will do that. Thank you. Lenin boy. Now the mudichikren Lenin boy. Huh? Okay. So now, so this is the error correction. Okay. So now, for example, it is a everyday data. Okay. So one day it will adjust 0.23. 20 that when there is a deviation, it will adjust 23%. So probably within 4 or 5 days, that deviation will get adjusted if it is a everyday data. So now this should be significant, and it should be minus. Okay. So this one, if it is 5 days, okay, how many days? 100 divided by this one. Okay, 1 divided by this one. Okay, it will do. So what equation I have written? D future. C I have not put. D spot. Resid -1. Okay, resid. So this is the angle Karankar error correction. Okay. So now we will go for this is a two this one, right? We will try to understand something more also. So by taking three variable now. So now let us take three variable. Okay. So now let me take three variable. So we will take mid, small, mid, large, all data you can take, So all will give the, sorry, I'm taking. Okay. So I have a three log. Okay. So let me take a log data first. Okay. So. Okay. So generate series. So L small. Okay. L small equal to log of small. Okay. Then generate L small I have considered L mid equal to log of mid. Okay, generate L large equal to log of large. Okay, log of large. So first, first I am taking 3. So now I am going to check whether they are point. Hello, madam. சொல்லுங்க madam. வணக்கம் madam. வணக்கம். நல்லா இருக்கேன் சொல்லுங்க madam. Very good madam. மகிழ்ச்சி. Very good madam. இந்த வெள்ளிக்கிழமை கிடைச்சிரும். சரி. அந்த இது ஆர்டிஐ எல்லாம் கிளியர் பண்ணிட்டீங்களா மேடம்? இப்ப அனுப்பிச்சு விடவா? சரி, நான் அப்போ அனுப்பிச்சு விடுறேன். அவரை நீங்க உள்ள வர வைங்க. சரி. நான் அப்ப அனுப்பிச்சு விடுறேன். ஓகே. சுதர்சன் இப்ப அனுப்பிச்சு விடுறேன். ஓகே தேங்க்யூ. அந்த மலர்விழி மேடம் கொஞ்சம் ஆர்டிஐ பிரச்சனை என்னன்னு பார்த்து அன்னைக்கே சொன்னேன் போன வாரம். Okay, so now I have a 3 data. I want to check whether they are co-integrated or not. Okay, so I can use this one error. I can say whether it is I0 or not. But now we are doing everything by using some tests. Okay, so now let me open. Okay, so let me open L small and L mid, because so small will the mid, that large companies will rise. So when all large companies rise means the small companies also will rise. So that is why large will influence small, mid will influence small. That is why first I am taking small, next is mid, next is. So first here you need to take the desired variable first, that you have to decide. We should decide dependent variable first. Okay, so now you open as a group. Okay, so here also we can run open as a group. Now co-integration test, Johansson co-integration. Here also you can type, or otherwise you can go to quick. Okay, group statistics, Johansson co-integration, both will do. Okay, so here also it is coming. Okay, I can use both. So now this will come, this we need to decide, this we need to decide, this we need to decide. Okay, so many things we need to decide here. One is, here there are many options available. So first is assume no deterministic trend, no intercept, and no intercept with no trend. Here we allow linear deterministic trend. Okay, we take intercept in co-integration equation, because every time we will allow intercept, every time in the equation we will allow intercept. Okay, and test the or. So now this has to be decided. But you can use this summary so that it will give for all, then you can decide. But first we will look at this intercept. Okay, with intercept in the co-integration equation, and test var. In var also we will use intercept. Okay, that is what everywhere we are using intercept. Okay, so now we will take lag interval of 2. Okay, lag interval of 2. So which means we are taking log the series, which means at level. Both are, all 3 are non-stationary data. All 3 are non-stationary. So now let me say okay. Then I will get a result like this. Okay, now we need to check whether they are co-integrated or not. So when we have 3 equation, okay, we will get 3 co-integration possible. 3 co-integration possible. So now okay, so this is there are 2 tests. One is called a trace test, another is called max eigen test. Okay, so both can be used. So, but when you have a large data, trace test is very useful. When it is a small data, 100, something like that, you can rely upon the max. Okay, but trace is little superior. But both are decided based on eigenvalue. See here, here also eigenvalue, here also eigenvalue. But the test value is that test T, how it is calculated, only there it is different. There only is different. Okay. So now we will look at this one. None. Okay, which means in the long run, coefficients are 0. Right? We set long run coefficients. That long run coefficients are 0. Which means there is no long run relationship. Long run beta, we said beta is equal to 0, no autocorrelation. Now in the long run, we say that long run coefficients are 0. That is the null hypothesis, which means no long term relationship. Okay, but now here we say that that is rejected. That is rejected, which means none. There is no co-integration. That is rejected, which means there is one co-integration. Okay, so now okay, or okay, it is rejected. Okay, which means it will have both. It will have not. Okay. Now, so let us go to the second one, which means accepted, which means at most one is accepted, which means one. So from this we can understand none is rejected, which means no one is rejected, which means one is there. Okay, one is accepted, which means one is there. So from this we can understand there is only one co-integration equation. So now you need not worry, it will tell here. Trace test indicates one co-integration equation at 0.05 level. Okay, so now we have a max eigen test. Max eigen test. So it says none or, which means no rank. Okay, the order of rank is none. Okay, order of co-integration matrix. Order of pi matrix, otherwise called order rank of pi matrix. Rank of pi matrix. Okay, so it is none rejected, one accepted, which means so one none is rejected means one, r plus one. Here null hypothesis is r is equal to 0. Alternate hypothesis is r plus 1, which means 1. Okay, that again it is here r is equal to 1 accepted, which means r equal to 1. So here also it is written. What is written? Also it is written. What is written? Okay, so it is having one co-integration equation. Okay, so which means there is a one co-integration equation. There is a one co-integration equation, right? Okay, so that is all about the whenever you take 3. Now, okay, so now we will look into the PPT so that we will try to understand something more. So this and all, will let us not look into it. Okay, we look at okay. So these two people, okay. So Robert Henkel. So this is the gentleman who has done this arch model, right? Okay, so and okay, arch model. There is another gentleman, Anchor. So he has also received the Nobel Prize for analyzing economic time series with common trends co-integration. So this gentleman, so he got a Nobel Prize for the invention. So this gentleman, he got a Nobel Prize for inventing arch. These two people, they have joined together and they have seen this Rob Yankel Granger co-integration. Okay. So now the term co-integration was first introduced by Engel in 1911 after the work of Engel, Granger Newbold on spurious recursion. So that gender, these two people, they have written okay, so article on spurious recurrence. Now they found it is spurious, but there is something in it. It can be predicted. It can be this one. So they have written something based on that. They could find out the okay. So now we learned that recurring two non-stationary variables result in spurious recursion. So if you recurse future on spot, you will get a spurious recursion. However, Yt and Xt are co-integrated. Spurious recursion no longer exists. When they are co-integrated, which means there is no spurious recursion, right? So how? Assume two series Yt and Xt are integrated of order Yt and Xt integrated of order I1, like future and spot integrated of order I1. Now, let us take Yt Xt. How will you write equation? By taking those Yt equal to beta Xt plus Ut. Okay, so I need not put star. I can put simply beta Xt. Okay. Now, same equation, I can write like this. Okay, Yt minus beta Xt equal to Ut. Right, this is going this side, which means Ut. Now we say that Yt is I1, I0. When Ut is I0, then this will be I0 because this is equal to this one. So that is why we say, though when Xt and Yt are integrated of order 1, when this linear combination is I0, this will become I0. So now let us see. If there exists a beta, okay, then what will happen? Yt minus beta Xt is equal to Ut, where Ut is stationary at I0. Then we say that Yt and Xt are co-integrated. Okay, so now we have done. Okay, we have done proc and make residual series, and we have checked that residual is I0. Yt and Xt are non-stationary, but the linear combination is stationary. Then they are co-integrated. Okay. Now see here, when Yt and Xt are integrated or order 1 are co-integrated, you need not have to difference. You need not difference. You can use OLS. Beta is super consistent. This beta is super consistent, which means this will converge to its true counterpart at faster rate than the whenever you use a delta Yt, delta Xt. Whenever you take a difference. Okay, so when we say I0 and this one, when these two are like this, not same order, definitely there is no co-integration because X moves are less constant over time. This is constant over time, but this is increases over time. So we cannot say when one is I0, one is I1. Okay, the graph, all these things I have shown. Okay, so now see this error correction mechanism. Very simple, please see. Okay, so now see here, Yt equal to C plus beta Xt plus Ut. That is what a normal recursion. Normal. Interceptor is also there, beta is also there. Now Ut is equal to Yt minus C minus beta Xt. Yt minus 1 is equal to Yt minus 1 minus C minus beta Xt minus 1. This is the error. This is the error. So the error is equal to this much. Error is equal to this much. Okay. So now error correction mechanism, that is what I have done. Okay. So delta YT difference. I put a difference, right? If you remember, difference I put difference future. Then C. Here also difference part minus. Okay, some coefficient will come. Okay, I put Z. I put Z minus 1. That is UT minus 1. Okay, UT minus 1 I should put UT minus 1. UT minus 1. Right. I have put Z within bracket minus 1 or resid within bracket minus 1. So here, okay, that is a coefficient. Here I put L D part D future, C D part. Okay, the coefficient will come. So here also I have put Z minus 1 because I am putting YT minus 1. This YT minus 1 is coming here. YT minus 1 is coming here. How YT minus 1? So this is the error correction portion. This is the error correction mechanism. See here. This is the error correction mechanism. So these are all we have studied. These are all we have studied. So this is what angle cranger. That is what when CT, that is difference of this one, the difference of this one plus error correction. This is what we have run. Okay. This is what we have run. Okay. Okay. So now, okay. So with this, we will stop today, madam. Hello, madam. Hello, madam.
Yes, sir. Yes, sir.
Madam.
Sir, I'm
with
here.
this, okay, with this, shall we stop today or we will continue? So I have to teach something more.
Sir, we'll stop today. It is
Okay.
12:30, sir. Many
Okay.
participants are requesting as they have many classes, all those things.
Okay, okay.